Speaking skill 18. Sample response, example question 6A. Page 310.
The lecture explains how the Persian Empire moved goods and ideas throughout the empire very quickly. The professor first points out that the empire has standardized coins and weights and measures. This made it easy for merchants to understand the different prices and amounts of goods in many different places, which led to an increased speed in trade. The professor also mentions that roads helped improve trade. She says that roads made travel and trade faster. As for movement of ideas, the roads also made communication faster and easier. According to the lecture, the king of the Persian Empire had a message system between the capital and the edges of the empire, which also improved communication. Finally, the professor indicates that many people spoke a common language, which also helped to speed up the spread of ideas.
Sample response, example question 6B. Page 311.
The lecture is about SAD, which is a kind of depression that appears in the fall, gets worse in the winter, and then goes away in the spring. The professor describes the cause and two treatments for this depression. First, the professor says that SAD comes from the lower amount of sunlight in winter. He explains that less light leads to more of a certain chemical in our bodies, which then results in depression for the people who suffer from SAD. After that, he discusses two effective treatments. The first is phototherapy, where the patient puts a light box in his or her house and then turns it on and sits in front of it for a while every day. The other treatment described is medications, but the professor points out that these can have bad side effects.
Speaking review exercise. Skills 16 through 18. Page 313. Listen to part of a lecture in a biology class.
Now let's talk about the structure of proteins, and let me start with the primary structure, and then we'll discuss the secondary structure. Now, as you know, proteins are made up of strings of amino acids hooked together. Think of it as a head and a tail. The heads hook together in a chain, one after the other. The heads are all the same, but it's the tails. There are 20 different ones. It's the tails that identify the amino acid. These 20 different amino acids can hook together in chains in practically an unlimited number of different combinations. This sequence, the order of which amino acid comes after another one, this sequence of the chain is called the primary structure of the protein. Again, as you know, each amino acid has different properties. Some dissolve easily in water, and others are more like oils and don't dissolve in water. Now then, secondary structures arise when long strings of amino acids interact with other parts of the string to fold in various ways, forming three-dimensional structures. That is, they have height, width, and depth. For example, parts of the protein composed of amino acids that don't dissolve in water will be tucked away inside the protein. In contrast, the amino acids from the chain, which dissolve readily in water, will be on the surface of the protein. The cells in our bodies are mostly water, after all, and that's where the proteins are floating. Now, other kinds of bonds can form between amino acids on different parts of the chain that forms the protein. Some of these bonds are weaker, and some are much stronger and give the protein a more secure structure. These different properties and bonds allow the protein to form in a very specific, three-dimensional shape that is essential to its proper function.
Using points and examples from the lecture, describe the primary and secondary amino acid structure of proteins.